Good evening. My name is Mirkamal Rakimov. Right now in this video I'm going to show and explain instructions which was given solution for the project. So first of all, to start, let's look at our problem. We are going to do the problem 2, which is DFS and spanning tree. Find the spanning tree for graph 1, which was done by the problem 1 in the past. Okay, try to draw spanning tree by coloring its edges green and count total lengths of edges. So this is our mission, and this is result have to be shown. Okay, and here's the example, the solution. We are going to take our graph 1. So here is the edges and vertices all was given, and we are using DFS function which was given in the PyCharm file which was provided, so which is discovered and if not discovered. So what is the basically this function does? Like it will go through all the edges and vertices, and it will define is it like discovered, or is it it was visited or not. So there is a construct pass. So this pass is going to be the empty pass, which is I'm going to show here, and it will first of all check is it discovered or not. If it's not discovered, like it's going to append these vertices to the pass. So and then the walk will equal to vertices, and the while function goes through all the u, and it will go to the parent function and find the edge leading to the walk. So here's the our function with the green coloring. In this case we have used network key x function as I used it in the problem 1, but in this time I used the functions which was given in the PDF, and at the same time I'm using network x. The vertices and edges we are giving, and here's the G, and which is NXC graph. We are creating the object from the new classes, which is an instance. So after that we are adding to our edges, and we are doing like minimum spanning tree G plus edges, which is the method which was used. So why you use spanning tree? Because it was asked from us from the PDF. For that reason I used the spanning tree. So this is right now following the rules of the PDF. So in this case, so in the situation I'm using the vertices and vertices using the zip function, which makes them like in the zip format, like which means like make them together, and we are making it green using some edges, some functions. So like in this color edge color function, which gives them the green color. So when I run them, as we show, like we can see this is the edges or the vertices, like how we can say. So this is the green path, like this is the green path, this is the green path. So this is same which was given in our PDF file. So, and the third one which was asked us is counting the length of this graph. So we run this. So in this case we are importing math function. We are using the math function in order to count vertex, edge, everything. So we are giving this as usual. We know that we can do it in the file format, but we can do it in this format as well in order to be understandable. If we do in file format, it's going to take time and it's not going to be understandable. So I did it in this format. So total length, it's going to be e equals 0 because there is nothing. So we are iterating over through edge and edges, and we are doing the square root of all these things, and we are putting these lengths inside of the total length. So we are using the length function, and in the end we are printing the total edges. So if I run, so we will see that total length of the edges in the tree is 5487.7 blah blah, and there is a problem 3 which was asked, so I'm going to show this as well. So problem 3, Problem 3 is asking us connectivity components, create and draw graph 11.dat. So this is the disconnected graph, so it consists of several connectivity components. Find the connectivity component and you need to write algorithm for solving this problem. So this is the result should have to be. So in this case we are using the same Network X library which was used, and we are using the Matplotlib pyplot as PLT as well in order to show our graph. So we are giving vertices and edges, everything here. So there is some okay, vertices and edges. So after that we run our function, so we can see the same result, and these functions are same which was given in the second problem and first problem, because we are using the Network X library. And as I said, so there is the disconnectivity like here, and this is the disconnected graph seems to be shown. So and it's the same like which was provided us in the PDF. So I used Matplotlib in order to visualize more beautifully, and I'm using Jupyter notebook in order to make it look beautiful. And here I'm using the find connected component which was asked. In this case this is also the same function which was given in the second also. It will go through the each neighbor in the graph, and DFC DFS and visited at vertices, everything it will go through for that. So we are using the example graph. So if we use this point and graph, it will go through the everything. So I will go this and this, so it will go through all the graphs, and this is disconnected. And this is the end of the explanation for the PDF and for the project question. Thank you so much. Thank you so much for attention.